mathematicians. Today, as a first problem, we see one very simple problem asked in a CSIR exam. Okay, a 3 by 3 matrix A is given. Okay, and it is said that the matrix A has a certain complex number lambda not equal to 0 as its eigenvalue. Okay, which of the following numbers must also be an eigenvalue of A? Okay, that is the question. So lambda is an eigenvalue of A is given, and it is also given lambda is not equal to 0. It is a 3 by 3 matrix, so it will have three eigenvalues. One eigenvalue is known, so there will be other two eigenvalues. They are asking among these four options which one of them will be an eigenvalue. Okay, so question is very simple to understand. Let's see how to proceed. Now one eigenvalue is given, so we take it lambda. Remaining two eigenvalues, we take it to be lambda 1 and lambda 2. Okay, so let lambda 1, lambda 2 be three distinct eigenvalues of A. Given that lambda is not equal to 0, now we calculate the trace of this matrix. What is trace? Trace is the sum of the diagonal entries. So trace is 40 plus 30 70 minus 50 20. Okay, so we get trace of A, but we know that trace is nothing but the sum of the eigenvalues. So we get trace A equal to sum of the eigenvalues lambda plus lambda 1 plus lambda 2, which is equal to 20. Okay, now we make some observation in the matrix. If you notice, first column equal to the negative of second and third column. Okay, yeah. So you take this column and this column, you sum. What will you get? Minus 40 plus 18 minus 26. Correct. Therefore, sum of these two columns is negative of first column. That means that, so we get minus C1 equal to C2 plus C3. Okay. Now, what is rank of a matrix? Rank of the matrix is nothing but dimension of the column space of A. Okay. What is the meaning of column space? You take the columns of a matrix and you take the linear span of the columns, you will get the column space. Okay. Now, since C1 is a linear combination of C2 and C3, dimension of the column space cannot be 3. Okay. Result, columns of A are linearly independent if and only if determinant of A is not equal to 0, if and only if rank of A is n. Okay, so this, if rank of A equal to n, it means that we say it is a full rank. Okay, so here we take A to be a n by n matrix. Okay, so this is a simple result. By using this result, we see that since rank of A, so A is a 3 by 3 matrix, but rank of A is strictly less than 3. Okay. From this result, rank of A equal to n if and only if determinant of A not equal to 0. That also means that rank of A is strictly less than n if and only if determinant of A equal to 0. Okay. So we get, since rank of A is strictly less than 3, we are A satisfies this condition. Therefore, determinant of A equal to 0. But what is determinant? Determinant is product of the eigenvalues. So, if product of the eigenvalue is 0, means that one of the eigenvalue has to be 0. So, we get 0 is an eigenvalue of A. Therefore, we get lambda, we take lambda 1 equal to 0. Now, already it is given that in the problem, trace is 20. Okay. Therefore, we get lambda equal to lambda 1 plus lambda 2 equal to 20. Now lambda 1 is 0, so we get lambda equal to, we get lambda plus lambda 2 equal to 20, we get lambda 2 equal to 20 minus lambda. Therefore, the correct option is 20 minus lambda. So, once some column is linear combination of other columns, you can always assume that the matrix has 0 as an eigenvalue in view of this result. Okay, this is a very simple but very powerful result. Okay, there is a much simpler way of seeing that this matrix has 0 as an eigenvalue, because you see this matrix has constant row sum. So this row sum is 0, this row sum is 0, this row sum is 0. So whenever a matrix has a constant row sum, say the row sum value is L. Okay. So for example, the sum of first row is L, sum of the elements of the second row is L, sum of the third row is L. Then this L itself will be an eigenvalue of the matrix with the corresponding eigenvector 1 1 1. Okay. So in our one of our problem we have proved all this result about matrices with the constant row sum very clearly. So I will give the link to that problem in the description. You can see that same link above also. Please check that problem also. Now, since this matrix has all the rows sum equal to 0, 0 will be an eigenvalue. So, once you know 0 is an eigenvalue, you can conclude that 20 minus lambda is an eigenvalue. Okay. Okay, guys. I hope you understand this problem clearly. If you have doubts, please let me know. Thank you.